So today let's look at Leetcode 1293, shortest path in a grid with obstacles elimination. So the question is you are given a m times n integer matrix grid where each cell is either 0 or 1. 0 means empty, 1 means obstacle. You can move up, down, left or right from and to an empty cell in one step. So return the minimum number of steps to work from the upper left corner 0, 0 to the lower right corner, give m minus 1, n minus 1, given that you can eliminate at most k obstacles. If it is not possible to find such work, return minus 1. So the example is there are two examples. The first one is that there is a lot of obstacles in this grid, and the k is 1, which means you can only eliminate one obstacle. So the shortest path after eliminating one obstacle is 6. So the output is 6. So and also the second example, k is still 1, but because there is no way to get from the upper left to the lower right, so the output is minus 1. So the question is getting to get the shortest path on a grid. So generally, it is using the BFS. So in this example, a little difference is we have a k, and also we can eliminate the obstacles. So in the past, I have done the question, but which is having obstacle, but you cannot eliminate. So that's the only difference. So what we can do is actually we can instead of adding this coordinates to the Q, we can actually add coordinate and also the number of k is the number of obstacles you can eliminate. So I mean, so in the end, we actually other part of the code is very similar to the traditional way of doing the grid using BFS. So also, yeah, also another is visited. So we actually need to we in the past we use like a two-dimensional visited. So now we actually need to use not one more dimension, which is added k to the also add that k dimension to the visited, so that we can now visit the same state twice. So actually, let's start coding, and so we can firstly get out the m and n. So m is grid length, and n is grid 0 dot length. Then we also we want to define a direction. So this one is used to get in the full direction for the when we exploring doing the BFS. So then we needed to define a Q. So also we needed to define visited. So the visited we can define as mn and also k plus 1, because the k's value will range from 0 to k. So then we can add we need to add the first state, the initial state is which is 0, 0, 0, 0, 0. So because there is a oh actually it's 0, 0 k. It's not 0, 0. So what k is it's remaining. We still have k obstacle remaining. So now we can start. Oh yeah, we also need to mark in the visited. So then we can start go through the BFS. So when queue is not empty, then we can also we need to have a steps. Keep like a recording the distance. So then we get the size of queue. Where the size is larger than 0, we can do the also steps. We need to increment. So then yeah, then we actually can start pull from the queue. So if here we can say if current is 0 is n minus 1 and current 1 is current 0 is m minus 1, current 1 is n minus 1. Then we return steps. In the end, if we cannot find it, then we return minus 1. So then here we need to start exploring the neighbors. So we can use that direction vector dir. So yeah, also we want to define a boolean called in area. A boolean function. So it's it will return true only when they are in the R and C is in the boundary. Okay, so if not in area, which means this is invalid, so we can continue. Then we then actually we also need to check if the grid is having obstacle. If it has an obstacle, then we need to we need to define a k1. So the k1 original value is current 2, but then if it is an obstacle, then we actually need to minus 1 from the k1. So if k1 is smaller than 0, then it means also it's invalid. Or k1 is not smaller than 0, but we have already visited that status. So then we actually can continue. So if it's then we actually here we need to mark it as visited. Yeah, then the last step here we need to add back this new status. Yeah, okay. So Yeah, okay. Let's check if it's passing any those two examples. So let me copy the example. Oh, here, right, here is wrong. So it should be I plus I and I plus one. So okay. So it passed the examples and um, let me submit it. Okay, so it passed. So in the end, let's just analyze this time complexity. So the time complexity is still, I believe it's still ON because it's a BFS. So okay, so yeah, so let's conclude today's session. And so if you like the video, please subscribe or click like button. And so if you have question or suggestion, just comment on the video. And thank you for watching. See you next time.